Hi everyone, so in this video we will see how to pattern on insulating substrate with pulse heating mode. So let's dive into it. I'm on a sample with the PPA and I want to import a geometry. So it is a Gaussian profile which I want to test with pulsed heating. Actually, instead of this Gaussian profile, maybe just have this, which is a little bit more simple. We set it as 2D, so it's always the same force, even though in this case we know that it doesn't really matter much if we have a force or not, because on insulating substrate we cannot apply any potential difference, so we cannot use any force. In the geometry transformation, we don't want to change much, and in the geometry settings, if we want, we can play with the pixels, and the depth even here doesn't mean much because again we cannot modulate any feedback, so it's just going to be a visual help or a visual target. Let's say we want to achieve 30 nanometers, and I import this layout. Okay, so now I go to the warm-up. In the warm-up, I import this layout. And now it's time to see which kind of parameters we need to change, play with to obtain a pattern. So first of all, we have to disable the force. So we don't want to apply any force on the right because we cannot apply it in general on insulating substrate. We may want to increase a little bit the temperature. Maybe we can set 1050. It's a little bit higher than the usual. And the forward height can be lowered. So let's put 180. Scan height, we can put maybe -50 because at the beginning maybe we may not be able to read the bottom perfectly to know which depth we're writing. And these are the typical parameters that we can change in the CLL runtime, but we also need to remember that we have to enable pulse heating here, otherwise we cannot do any pulse heating writing. And this also allows us to play with the heat pulse. So usually heat pulse is around 15 microseconds or 20, the standard value. In this case, we can set any arbitrary value really. So let's say 30 microseconds, and see if I refresh these values here, then it goes to 25. So now I put 30 here so that we optimize also the pixel time. And I'll say we're good to go to try our first test. We changed heat pulse, pulse heating, and now we can press play. As the temperature can still be changed when we write our field, we can also see how the temperature affects our patterning and our thermal bending. In general, as you can imagine, as we increase the temperature, we also increase the thermal bending effect. So now it's probably too low. I will increase it to 1100. I'm not able to write, so maybe I put 1150. Just too low. But we may have had some problems here for the approach. So let's try it again. Oh, the scan height is wrong. So we are not actually reading the surface. It's my bad. So let's put -50. And let's put back 1050. Can increase it. $1,250. Probably this was not taken well by the software. Let's try one last time. Maybe even with higher forward height. Now it looks like the reading is a little bit better. Indeed, we're able to write. We're writing very deep. So maybe let's decrease the temperature. And we will decrease the depth. Let's decrease it even more. Maybe 1100. Now it's too little. Probably 1200 was good, but we need to tune it a little bit. Anyway, we can already see that we're able to write with this pulse heating mode. And just to make sure that we don't believe me that I'm using zero force, we can check here that we are indeed applying a zero force. So all the bending that we see here is a thermal bending. Maybe let's reduce a little bit more the forward height, so we put ourselves closer to the surface. This should allow us to have a more effective writing, because thermal bending will put us more in contact to the surface as the forward height is decreased. So let's try to write it again. Let's also check that our approach is okay. Probably we may have picked up some contamination as the adhesion length is no, since everything is okay, never mind. As we see here, this value we're not able to write earlier, but by lowering the forward height now, still okay. And even with 1100 Celsius, we see that we are able to write this this pattern. As you see here, it's not that great. Maybe the tip also is not in the best shape, or the temperature is not so is not high enough. But definitely we can see the effect of the temperature over the thermal bending. We decrease the temperature, and we decrease also the depth of pattern. And in this case, we're using zero force. And by playing, I will say mostly with forward height and writing temperature, but also heat pulse, you should be able to tune well your writing. And again, in this case, we don't really have a feedback, so you have to check and adapt live. So you are the living feedback, and need a little bit of experience in tuning the patterning parameters to effectively pattern with this mode on insulating substrates. But I wanted to show you also one last thing, which is that when we write with this mode, we cannot really write in grayscale, because the temperature is always the same on the heater of the writer. So let's import a grayscale design. let's actually make it grayscale. So here we see that we have a different force profile, because this is geometry that will that is related to the force that we use to bend the cantilever, but we cannot use the force. So this is anyway the design that we can use to turn on the heater. So the heater will be turned on with pulse heating where the pixels are not white. So even here, for example, the temperature is going to be the same as it's here. So we will not see any grayscale in the pattern. And here there are some problems with this design because there are some white pixels here, which are probably not the best, but it's just a way to show you how this pulsed heating on insulating substrate patterning works. So let's import this design and select it. This is how it looks like, and what we expect to see, at least what I expect to see, is basically a donut. So we will not see any grayscale here, just a donut. And let's check that it's actually going to look like a donut. Maybe I put a slightly higher temperature, 1100, and let's say 40. Just change value to make it more fun. And let's now check the results of our pattern. By the way, I kept the same parameters here for the heat pulse. We got an error here, so let's start the operation. And now we see already that we are writing. We don't see any grayscale. It's pretty much always the same depth, because the temperature of the heater is always going to be 1140 from here to here on all the black pixels. Of course, here, for example, we only have one white pixel, where the temperature of the heater should be 0 technically, but it's being only just one pixel, we have the merging of the other pixels on the left and the right, so it will look like a continuous pattern in the end. So as expected, we don't see any grayscale. We will soon see the whole of our donut. We can also see our donut in 3D. And I will say this is already covering what I would like to show you in this video. And in case you would like to explore patterning in grayscale on insulating substrate, I will recommend you to watch the video with the temperature map patterning, because in this case we cannot, as we're seeing now, pattern in grayscale. And now we're starting to see the whole of our donut where the heater is off. So I hope this helped in your cases, and good luck your research. I will not let you see the finished donut because it's going to be quite boring. So thanks for watching, and see you in the next videos.